Welcome to Lesson 7, Systems of Linear Equations in Two Variables. First of all, let's talk about what a solution looks like and what it means to be a solution. So a solution to a system of linear equations in two variables is going to be in the form of an ordered pair. So for instance, it's possible that this ordered pair, where -3 is our x value and 5 is our y value, could be a solution to this system. So a system of equations is one or more equations that are grouped together. And for an ordered pair to be a solution, it must satisfy all of the equations in that system. In other words, we're going to plug in this point for x and y in the first equation and see if we get a true statement. Then we'll plug x and y into the second equation and see if that gives us a true statement. If we get a true statement in both equations, then that ordered pair is a solution to the system. So let's do that. So first of all, does -3, 5 satisfy the first equation? So we have 2x plus 6y equals 24. So we'll plug in -3 for x. We'll plug in 5 for y. We'll do the math and see if it gives us equal values on either side. So 2 times -3 is -6. 6 times 5 is 30. And -6 plus 30 is in fact 24. So because that ordered pair gave us the same value on either side, it is equal, so it does satisfy that first equation. But to determine if it's a solution to the system, it also has to work in the second equation. So let's do that. So we're going to see, does -3, 5 satisfy the second equation? So again, we're going to plug in, -3, 5 into the second equation. So we have x plus 5 times y, and we want to see if that will give us 3. So plugging in that same ordered pair, -3 plus 5 times 5, which would give us -3 plus 25. And we want to see if that's equal to 3. Well, -3 plus 25 is 22. And 22 does not equal 3. So because that ordered pair did not satisfy both equations in the system, it is not a solution to the system. So let's look at example 2. Example 2 is a fraction, or y-coordinate is a fraction, but we still handle it the same way. So if we call this equation 1 and this equation 2, let's first plug in 0, 1/2, where x is 0 and y is 1/2. So we have 5 times 0 plus 10 times 1/2, and we want to see if that's equal to 5. Well, 5 times 0 is 0. 10 times 1/2 is 5. Half of 10 is 5. Or if you want to think about it, 2 will go into 10 5 times. 5 times 1 is 5. 1 times 1 is 1, and 5 over 1 is 5. So 0 plus 5 is 5. So we did get a true statement. Let's look at equation 2. 22 times x minus 6 times y, and we want to see if that's equal to negative 3. So again, we're going to plug in that same ordered pair, 0, 1/2. 22 times 0 is 0. Negative 6 times 1/2 is negative 3. And 0 minus 3 is negative 3. So in this case, the ordered pair satisfied each equation in this system. So 0, 1/2 is a solution to the system. So let's make a note up here, and let's say this: in order for an ordered pair to be a solution to a system of equations, the ordered pair must satisfy every equation in the system. And there's my abbreviation for equation again, EQ apostrophe N. So the solution to a system of equations in two variables is going to look like an ordered pair. And for it to be a solution, it must satisfy every equation in the system.